This is a signal. Over the past decades, astronomers have recorded thousands of unusual cosmic signals, but one of them made researchers stop and think. Its structure is so unusual that it doesn't resemble the familiar radiation from stars or any known cosmic sources. Some pulses repeat with frightening precision, as if someone is persistently trying to attract attention. What's really behind this mysterious signal?
On April 29, 2019, the Parkes Radio Telescope in Australia detected a strange radio signal coming from the direction of Proxima Centauri, the star system closest to the Sun. The frequency of this signal is 980,000 megahertz, which is usually used by satellites. It has all the properties of a radio transmission that natural sources don't have, and that can only be achieved using artificial technologies. During observation, this radio signal shifted a little, which resembled the shift caused by the movement of a planet. What does all this mean? According to The Guardian, this is the first serious candidate for contact with an extraterrestrial civilization. At the moment, scientists are scratching their heads. How can this phenomenon be explained? It's an interesting coincidence that this constellation is home to the exoplanet Proxima b, one of the closest known planets to us, where life similar to Earth's could have arisen. What are the chances for humanity to colonize this planet? How many people would be needed for such an expedition? And if life already exists there, will the local inhabitants welcome us? Hello? If life did originate in Proxima Centauri and is sending us signals, it must have happened on the planet Proxima b. The thing is, it is located in the so-called habitable zone, a notional region which, according to calculations, provides the planet with conditions as close to Earth's as possible. The planet orbits at a distance of about 7 million kilometers from its star, Proxima Centauri c. For comparison, the distance between Earth and the Sun is about 150 million kilometers. However, the star Proxima Centauri c has a lower luminosity than the Sun. Therefore, the local exoplanet receives just enough heat for water on its surface to exist in liquid form and not freeze into eternal ice. And the local temperature here is probably about the same as on Earth. In terms of mass and size, Proxima b turned out to be almost a twin of Earth, 1.17 times the mass of our planet. What does this mean for us, the inhabitants of Earth? Perhaps we should leave cold Mars alone and turn our attention to a more attractive candidate for colonization. Is it really possible for humans to settle on Proxima b? I'll answer briefly. It's possible. But the problem is that it's very far away, 4.24 light years. Such a flight would be long. At such a speed, humanity would be able to reach Proxima b in about 6,500 years. However, by the time interstellar travel becomes possible, technology will help reduce this time to 630 years. If your ancestor, who traveled during the Crusades in the 14th century, suddenly set out on this interstellar expedition, it would be only now that you would be able to land on Proxima b. So I have some bad news for you. If you go on such a journey, you are unlikely to live to see its end. But there is also good news. Instead of you, your great-great-great-great-great-grandchild will be able to reach Proxima. How many people would be needed for such an expedition? To calculate the ideal crew for colonizing Proxima b, French scientists used a special program called Heritage. It is based on the so-called Monte Carlo method, which calculates all possible scenarios, including the life and death of crew members. Random factors are also taken into account, even disasters and diseases, which vary depending on the number of people who are most likely to be susceptible to them. As a result, French scientists managed to find out that to organize a successful spaceflight to the planet Proxima b, only 98 people would be needed. 49 men and 40 women. This exact number of astronauts would allow the crew not only to survive, but also to produce healthy offspring and completely eliminate inbreeding, except for the early stages of the flight. The optimal fertile window turned out to be between the ages of 32 and 40. By having children during this period, people will be able to ensure a stable population growth on the ship and maintain a balance between young and old crew members. In addition, in this case, an epidemic that occurs in the middle of the journey will not lead to the deaths of all expedition members. But let me remind you, before the first Earthling reaches the exoplanet, about 6 generations will have passed aboard the spacecraft. Many people will spend their entire lives only on the ship. Their whole world will be limited to spaceflight and gazing at the stars. Their immune system and physiology will become different. They will never see the sky or the sun. Although I think their minds could be immersed in a virtual world where they could experience all the richness of life on Earth. What will happen when they finally reach their destination? There are several possible scenarios here. The first scenario, there will be no water or air here. First of all, because of its proximity to the star, Proxima b could very likely have undergone a runaway greenhouse effect. This, in turn, would have led to the complete drying out of the planet and the evaporation of its oceans. For example, the same thing once happened to Venus. Secondly, in this zone, the planet would have been under continuous exposure to harsh radiation and solar wind, which would also eventually lead to the loss of water and atmosphere. Thirdly, scientists recently recorded a flare that increased the star's brightness 1,000 times in just 10 seconds. To survive such events, Proxima b would need to have a magnetic field as strong as Earth's and a dense atmosphere. But for now, we know too little about the history of this planet, and recent calculations give hope that it still might have preserved conditions for life as we know it on Earth. The second scenario, we will land on an inhabited planet. According to scientists from NASA, Proxima b might still be habitable. If we assume that Proxima b formed farther from its star and only later moved to its current orbit, then the planet could have avoided overheating and radiation, preserving water and air. In addition, it's possible that the planet originally had a lot of water, maybe even 10 times more than Earth. Then even if Proxima b lost 90% of its moisture, there would still be enough left for an entire ocean. But what about the radiation flare that scientists recently detected? There is a possibility that the planet was originally surrounded by a dense hydrogen cloud, which absorbed the impact of the star's intense radiation and evaporated, leaving behind a life-supporting atmosphere. In that case, our expedition will land on a green planet suitable for habitation. It is possible that intelligent inhabitants will live there. What do you think? How will they react to immigrants from Earth like us? I think that the instinct for survival and protecting one's territory is something that is inherent in every living creature. So even if the locals turn out to be humane, they are unlikely to be happy to share their planet with us. The third scenario. The third is that we encounter an alternative form of life. Usually when we search for extraterrestrial life, we assume that it must have formed in biochemical conditions similar to those on Earth. However, what if life could have formed even on a planet where there is no air or water? For example, biologist Jack Cohen and mathematician Ian Stewart argue that astrobiology based on the rare Earth hypothesis is limited and dull. They suggest that life could have arisen under other conditions, but not based on carbon. As an alternative to carbon, silicon is most often mentioned, and as an alternative to water, ammonia. Thus, we can assume that on Proxima b we might encounter strange, very different beings who managed to build an advanced civilization and send radio signals to other constellations. Who will prove more intelligent? them or us? Write your opinion in the comments. However, even if we successfully reach Proxima b and the locals greet us, so to speak, with open arms, I'm still concerned about the awkward detail you heard earlier. The flight will take 630 years. I don't know about you, but I wouldn't board a ship knowing I wouldn't make it to the end. What can such a flight be compared to? For example, when the ancient Greeks thought about traveling to Mars, they calculated that even the fastest horse would take several tens of thousands of years to get there. All the horses in the world at that time wouldn't have been enough. Just like now, all the energy on our planet isn't enough to reach Proxima b within 100 years. But those same ancient Greeks couldn't even imagine that in 2021, we would be routinely flying to Mars, receiving regular photos from there, and organizing its colonization. Do you understand what I'm getting at? We have understood the universe on some level, but to accelerate to higher speeds, we also need to delve into the atom and understand how all of this works. Take chemistry, for example. All rocket fuel is based on chemical reactions, but we still don't know what gravity is, how it works, or what role it plays if you're flying through outer space from one star's gravitational field to another's. Someone will eventually come up with the equivalent of a modern engine for traveling between star systems. It will be something fundamentally new, something that's hard to even imagine right now. And here I have some good news for you. There are already some interesting developments. Wherever you are right now, whether in the scorching heat of Africa, among the harsh archipelagos of the Arctic Ocean, or in the mystical Himalayas, look up at the sky. It is adorned with a magnificent necklace of trillions of stars, but there is one spot unrelated to the stars that cannot be seen with the naked eye. This is a man-made object, the man-made object that is farther from Earth than any other spacecraft. We're talking about the American space probe Voyager 1, launched in 1977. Do you think it went silent long ago? You're mistaken. The probe is still sending signals to Earth, and sometimes they puzzle astronomers all over the world. For example, recently Voyager 1 picked up a steady hum of unknown origin. Editor. What could this mean? Astrophysicists are still puzzled. What tasks is Voyager 1 meant to accomplish, and where is it now? The main mission of the spacecraft was to study the giant planets Jupiter and Saturn. It is worth noting that Voyager 1 carried out its mission brilliantly. It was Voyager 1 that gave the world detailed images of the massive celestial bodies made of swirling gas, as well as their rocky moons. But that was only the first stage. The most difficult part awaited the probe ahead, and it began carrying out this crucial task relatively recently. Voyager 1 was given the enormous responsibility of studying the Kuiper Belt and the boundaries of the heliosphere. But how can we interpret the data obtained if no one has ever been to regions of space so far from Earth before? In a way, it's like traveling with an incomplete guidebook where the vast majority of information is simply missing. It was there, billions of miles away from its home planet, that Voyager 1 detected a persistent hum coming from an unknown source, which most likely originated from interstellar space. During its 4 decades of travel, the spacecraft recorded various signals, but this was the first time it detected something like this. And considering that Voyager 1 is literally feeling its way through regions where the entire solar system, led by its star, will eventually arrive, the information it has gathered becomes especially relevant. Would you like to learn more about what Voyager 1 is studying? Our planetary system, centered on its star, is located in a giant bubble called the heliosphere. All the planets of the solar system, along with the Kuiper Belt, are under the protection of this invisible shell. It reliably shields these objects from the aggressive interstellar environment. So, what is the heliosphere and what are its characteristics? It is a vast region where the plasma of the solar wind moves at supersonic speeds. At the boundary with interstellar space, the solar wind collides with the plasma and magnetic field of outer space. To put it simply, the solar wind accelerates to high speeds, twists into a spiral, and then suddenly slows down as it hits a weightless barrier and gradually mixes with cosmic particles. Voyager 1 is currently located near the boundary of these phenomena, which means that's exactly where the spacecraft detected the mysterious signal. How difficult was the journey of the spacecraft before it reached the outskirts of the solar system? Where is the probe traveling? How did it travel? And what stages has it already passed? In 2004, Voyager 1 crossed the shockwave boundary. This is the heliosphere region where the solar wind slows down significantly before meeting interstellar matter. How did scientists on Earth learn about this? Of course, the conclusions are based on the data from the spacecraft's instruments. Yes, as mentioned earlier, after 43 years it is still sending signals, although not all of the sensors on board are working properly. Anyway, let's continue. Beyond the shock wave lies the heliopause, where the solar wind finally calms down and mixes with the matter of deep space. The structure described is known to astronomers indirectly, since apart from Voyager 1, no other Earth-made object has ever ventured so far into the pitch-black darkness of the universe. That makes its message all the more valuable to us. For example, there is a hypothesis that between the boundary of the solar system called the bow shock, which follows the heliosphere, there is a hydrogen wall filled with hot gas. Isn't that the hum Voyager 1 sent us? The signal consists of vibrations in a certain frequency range and could very well serve as confirmation of this theory. Unfortunately, it's impossible to measure the pressure and density of the plasma, as well as its temperature, because the instrument stopped working on Voyager 1 back in 1983 years after launch. But the other instruments are still active and scientists rely on them. The plasma wave instrument and the cosmic ray detector are still diligently sending us information. Thanks to the latter, it was possible to record an increase in the level of cosmic rays and high-energy electrons as Voyager 1 approached the boundary of the heliosphere, which it successfully crossed on August 25, 2012. According to scientists' predictions, the spacecraft will be sending signals at least until 2025. The probe's power supply is provided by radioisotope generators running on plutonium-238. At the moment, their power output has decreased by half. But let's return once again to the mysterious hum detected by Voyager 1's instruments. What other hypotheses, besides the ones already mentioned, do scientists consider to explain this strange phenomenon? The fact is that similar vibrations are also caused by plasma waves of various origins. For example, they can be triggered by major solar flares. Some astronomers suggest that the space at the boundary between the solar system and interstellar space has a structure similar to foam. This happens because small cosmic objects form small spheres around themselves, similar to magnetic bubbles. It is possible that this also leads to the strange vibrations detected by Voyager 1. By the way, the sound of the mentioned signal is similar to a distant ringing, periodically interrupted by strange irregular bursts that resemble bell strikes. It gives the absurd impression that someone is sitting astride the space probe and banging on its hull. Has the human-made spacecraft finally left the boundaries of the solar system? Not at all. According to NASA's calculations, this will happen in about 30,000 years. Right now, the probe is passing through a kind of cosmic inferno, But unlike the companion in Dante's Divine Comedy, the spacecraft is completely alone and has no companion whatsoever. The boundaries of the solar system extend much farther than the Kuiper Belt and even the heliosphere. It will take about 3 centuries, and Voyager 1 will plunge headlong into the Oort cloud, if it actually exists and is not just in scientists' imagination, since no one has ever actually seen this formation. It is believed that the comets that sometimes enter the solar system are actually visitors from this very cloud. What will happen next? As soon as Voyager 1 leaves the boundaries of the giant torus, the spacecraft will embark on an eternal journey through the Milky Way, and we are unlikely to ever learn about its fate unless the villainous golden record with Earth's sounds and other information falls into the hands of extraterrestrial civilizations. Unfortunately, modern astronomy is in many ways like reading tea leaves, although of course the science of stars has advanced significantly compared to previous centuries. It's hard to imagine what else Voyager 1 will discover on the outskirts of the solar system. And most importantly, how can we decipher these signals? For now, the spacecraft is about 20 billion kilometers from Earth, cutting through outer space at a speed of 60,000 kilometers per hour. Its research is very valuable for science, because thanks to it we can lift the veil of mystery a little and learn what interstellar space is made of and how it behaves in its natural environment. In addition, this will allow us to take past mistakes into account when designing new probes that will be even faster and more reliable. And while Voyager 1 literally has nothing but ringing in its ears, let's enjoy the comfortable conditions on Earth and the ability to easily get any information about the vastness of space without leaving our favorite couch. Imagine you're searching for a diamond lost on the beach. Every now and then, it seems like something sparkled amid the shimmering sea of sand, but it's just a shard of glass, and disappointment washes over you again. Why do you think we're painting such strange pictures in your mind's eye? That's exactly how you can describe the feelings of astronomers who are unsuccessfully trying to detect extraterrestrial signals. For years, scientists have been peering intently into the darkness through telescope eyepieces, but the meteor-streaked cosmos stubbornly remains silent, keeping its grim secrets hidden. However, sometimes the silence is broken by rare signals of unknown origin. It's important to understand that there are many objects in the universe capable of revealing themselves in one way or another, with blinding light, energetic pulsations, or radio bursts. And it's the latter that we'll talk about now. What are these phenomena, and what sensational discovery has recently shaken the scientific world? This fall, astronomers were baffled by unprecedented activity in space. In just a month and a half, more than 1,600 radio signals reached Earth, whereas previously, such messages were at best counted in the dozens. At times, the instruments recorded up to 150 signals in just 1 hour. This shocked scientists, especially since fast radio bursts are considered the most inexplicable phenomenon in the universe. What are single radio pulses and where do they come from? Fast radio bursts have been known to science for a relatively short time. They were discovered in 2007. Like many phenomena in astronomy, the discovery was made by accident while analyzing data related to observations of pulsars. The duration of the signal was only a few milliseconds, but the energy of the event that produced it is beyond description. It is equivalent to the energy emitted by our star over several days. The energy emitted by our star over several days, and all of that in a fraction of a second? Honestly, it's hard to believe. And yet the fact remains. The radio signal was detected, so astronomers began to study it. It took the group of scientists a whole 5 years to verify whether the FRB 010724 burst really came from deep space. and wasn't caused, for example, by an ordinary electrical appliance. So, a detailed analysis showed that the radio burst lasting less than 5 milliseconds came from the depths of the dwarf galaxy known as the Small Magellanic Cloud. And the distance to the object that produced this signal was incredible, about 3 billion light-years, or 1 gigaparsec. Since no other signals were received, the group of scientists from the State Association of Scientific and Applied Research concluded that such phenomena are very rare in the universe. How wrong they were. Let's pause for a moment and pay attention to the obvious discrepancy between the duration of the signal and the energy that produced it. Doctor of Physical and Mathematical Sciences, professor of the Russian Academy of Sciences, Sergei Popov openly mocks this paradox in his lectures, claiming that such radio signals cannot possibly be the result of extraterrestrial life. You have to agree it's completely illogical to spend such a huge amount of energy just to send a single signal. Then the next question is, what exactly is capable of generating such powerful radio bursts? To answer that, it's worth recalling the words of Sergei Popov, who reminds us that we've already encountered a similar phenomenon when studying gamma ray bursts. In Soviet times, it was believed that this type of radiation was caused exclusively by atomic bomb explosions. That's why spy satellites were regularly launched to detect such bursts in order to warn the governments of countries involved in the Cold War about potential dangers. As it turned out, coincidence once again played a leading role here. Thanks to active monitoring of outer space, it was discovered that the sources of gamma ray bursts can be objects millions of times more powerful than any atomic bomb, and these monsters are infinitely far from our planet. The final realization came only after 30 years of meticulous observations. At first, astronomers couldn't understand at all where the dozens of powerful signals were coming from, whether their source was within the boundaries of the solar system or far beyond our galaxy. Of course, because of this, there were people who speculated about messages from alien civilizations. Movies released in the 90s, such as Contact, also contributed to this mindset. Jodie Foster's character caught a signal in exactly this way, indicating intelligent life in the universe. However, it was not a gamma burst, but a radio burst. Well, it's like they could see into the future, however we've gotten sidetracked. As for gamma ray bursts, scientists later figured out what phenomenon manifested itself in this way. It turned out to be a supernova explosion. But things aren't so rosy with the radio burst. If you look closely at the graph showing the first radio signal of unknown origin, you can conclude that its source is very far from Earth, and the energy that caused this burst is equal to 10 billion times the sun's luminosity in just 1 millisecond. What's even more interesting is how such power could fit into the radio frequency range. For example, gamma ray bursts are much easier to explain since they even occur on Earth during nuclear bomb detonations. And by the way, they hardly show up in the radio frequency range at all. Of course, this hasn't brought us any closer to solving the mystery of these bursts. Again, if this is an alien civilization, then it's extremely wasteful. So much energy literally wasted. But, as with any important task, there have been minor obstacles on the way to solving this extra tricky puzzle, confusing the scientists. What was the holdup? A funny incident interfered with the astronomical investigation this time. The fact is that at the Parkes Observatory in Australia, located in New South Wales, some inexplicable things were once discovered. The instruments began to detect similar radio signals, and with strange regularity. They were attributed to all sorts of things, a passing airliner, lightning discharges, and more. But the answer was obvious. It was just an ordinary microwave oven used by the observatory staff. Hungry scientists would open the oven door before it finished working, so radio waves would escape, and that's what the equipment detected. When everything became clear, the astronomers began to check the very first FRB 010724 signal, also known as the Lorimer burst. But according to a detailed analysis, it turned out to be genuine and had nothing to do with terrestrial radio equipment. So is the Lorimer burst still the only one that has been detected so far? Of course not. In 2013, after a series of false reports, the sensors delighted astrophysicists again by picking up several more millisecond signals. After that, it was concluded that there are actually a lot of such bursts in the universe, possibly several thousand events per day. But the question remained, what is generating these signals? Until recently, scientists could only determine the location from which some of the burst originated. In 2019, a single pulse with the code number 180924 was detected. It turned out that it came from a distant galaxy in the constellation Grus, which is located 4 billion light-years away from the Sun. But in 2020, for the first time, a source was discovered that generated a monstrous burst. It was a neutron star with an incredibly strong magnetic field, located in the constellation Vulpecula of the Milky Way galaxy. At the moment, scientists have nothing new to tell the public. They still don't know for sure what causes these immensely powerful radio bursts, and there is no single scientific hypothesis. But there are a few interesting hypotheses. First of all, it's worth mentioning the hypothesis of Avi Loeb, a professor at the Center for Astrophysics. Scientists believe that radio bursts may be the result of activity from certain stars in our galaxy. Alternatively, we have to agree that extragalactic sources are to blame. For example, some exotic events, the collision of neutron stars, the transformation of a supermassive pulsar into a black hole, or the result of magnetar activity. As you can see, there's not a word about extraterrestrial civilizations. But don't think that during this time, scientists haven't achieved anything. Now we have the ability to detect signals from the same source and also catch radio bursts more frequently. It's very important. Soon things will move faster, and the Chinese Fast Telescope, as well as the CHIME radio telescope, will help with this. CHIME, which is installed in British Columbia, one of the provinces of Canada. The latter is capable of efficiently scanning the sky, detecting new radio bursts. As for the spherical telescope located in China's Guizhou province, it will serve not only as a signal detector, but will also allow the study of the evolution of dark matter and distant stars. It will also help solve other scientific problems. By the way, just a few years ago, anyone could take part in the search for radio signals. What did you need for that? Just join the SETI project, which allowed you to detect radio bursts without leaving your home. This non-profit platform ran on the BOINC platform using the computing power of home computers. Unfortunately, the project is currently frozen. Since April 2020, SETI at Home has stopped sending tasks to its users, but there are several alternative options for searching for gravitational waves, as well as creating a three-dimensional model of stellar streams. Finally, it is worth noting that the hypotheses put forward by some scientists are questioned by other astronomers. There are about 36 magnetars in our galaxy, yet instruments haven't detected anything resembling fast radio bursts from them. Anything resembling fast radio bursts coming from these, some Christian signs will not pass through the world. Isn't that true? Write your thoughts in the comments, have a discussion, and at the same time, leave a like and subscribe if you haven't already. Not long ago, scientific communities were still trying to prove whether it exists. We think, to determine that the hypothesis is not fixed. Maybe that's what we think. That's what we think. Maybe that's not what we think, not the way we think. Recent space missions have shown that this is far from the case. Just listen to the sounds that Voyager 1 recorded in space. How could it have appeared in a place where no signs of life have been detected? These are far from all the discoveries we've made during the Voyager mission. Before that, Voyager 2 discovered information that made scientists reconsider the established data about the density of interstellar space. Circumstances worked out so that we were able to learn about this only now. What are they actually like? What are Voyager 1 and Voyager 2? What is the difference between them? And which Voyager turned out to be more useful for science as a whole? The original mission of these spacecraft was to study the 4 largest planets in our system, namely Neptune, Uranus, Saturn, and Jupiter. According to NASA scientists, in the second half of the 20th century, these celestial bodies were expected to be positioned in such a way that gravity would help increase Voyager's speed. If they had been launched either too early or too late, the mission could have been considered a failure. It was important not to miss the moment, because the planets would be in the same position again only after 176 years. If the mission had failed, we wouldn't have had recordings of space noises or unique photos of the giant planets at our disposal. So, what were the differences between the 2 spacecraft? In terms of specifications, they are absolutely identical. The length is 2.5 meters, the weight is almost 800 kilograms, 16 thrusters, and a memory unit for storing 67 megabytes of information. You probably have a question. Since the Voyagers are practically identical to each other, why do they differ so much in effectiveness? The mission began at Cape Canaveral in Florida in the summer of 1977. That's when scientists launched Voyager 2 into space. Its twin brother was sent 16 days later. Since then, both spacecraft have been exploring space, and the difference in launch times put Voyager 1 and Voyager 2 in different conditions. So how did both spacecraft operate in space? Although Voyager 2 had been in space longer than Voyager 1, it was Voyager 1 that initially had more advantages. That's because the spacecraft performed gravitational maneuvers, which allowed it to reach Jupiter several months earlier than its twin brother. In the spring of 1979, Voyager 1 added to its list of achievements by providing data about 2 previously unknown moons of Jupiter and photographs of volcanic activity on another of the giant planet's moons. Voyager 2 was also busy trying to catch up with the other spacecraft. This paid off, and soon data appeared about a new moon of Jupiter, Adrastea, as well as the first images of the planet. As for the moon, it is located in one of Jupiter's rings, and it is impossible to detect it by observing from Earth. If it weren't for Voyager 2, we might never have learned about Adrastea. How did things go with Voyager 1? In the early 80s, it provided images of Saturn and data about its new moons, Pandora, Atlas, and Prometheus, like Prometheus. The information was processed on Earth. Voyager 1 changed its course and headed beyond the boundaries of our solar system. Voyager 2 also reached Saturn 9 months later and took pictures of the planet. After that, the spacecraft reached Uranus and took pictures of it to gather information about its temperature conditions. That's how we learned that Uranus can be classified as the planet with the lowest temperatures in the solar system. Specifically, that's almost 60 Kelvin, which is minus 214 degrees Celsius. Voyager 2 didn't stop there, and just 3 years later it photographed Neptune, capturing storm activity in the southern region. The probe became the only spacecraft to explore 4 planets in our solar system. In this, Voyager 2 surpassed its twin brother. After exploring Neptune, it stopped the operation of its recording devices and set out to study the space between the stars. Let's get back to Voyager. It was also supposed to stop the operation of its recording devices, but before that, while it was 6 billion kilometers away from the Sun, on February 14, 1990, it took a picture of the solar system known as the family portrait. And one of the most popular and incredible pictures was called the pale blue dot, which shows our planet Earth. So both Voyagers have left the solar system. What awaited them beyond its boundaries? Voyager 1 broke another record, becoming the most distant human-made spacecraft from Earth. Let's add to that a record-breaking speed of 17 kilometers per second. With such performance, Voyager 1 flew through the region of solar winds and ended up directly in interstellar space. But Voyager 2 in 2012 earned the title of the spacecraft that has been on a space mission the longest, since 1977. The most interesting part began in 2018. As soon as Voyager 2 entered interstellar space, it immediately detected something strange. Since our school days, we've been told that space is absolutely silent. It's a vacuum, but it turned out to be different. The fact is, the density of solar winds is about 10 particles per cubic centimeter. When crossing the edge of the solar system, the density is already 2,000 electrons. However, when Voyager 2 was already at a considerable distance from the Sun, almost 19 billion kilometers,
15 миллиардов километров,
they recorded an increase in the density value up to 0.12 electrons. Right now, scientists are not ready to name the specific reasons for this phenomenon, but with new data in the future, the situation could change dramatically. Let's pay a little more attention to Voyager 1, especially since its discoveries are no less interesting. Listen to this sound. This is how plasma vibrates, which is most commonly found in outer space and is a component of stars. Such plasma appears when the plasma of the Sun collides with the space between the stars. There's nothing extraordinary about this, but 4 years ago, in 2017, an instrument on Voyager 1 detected a faint, only 3 kHz but continuous signal in space. It lasted for about 3 years. All this time, Voyager 1 was moving away, increasing the distance, but the frequency of the signal remained the same. It's already been 44 years since the Voyagers began their space mission. And what will happen next? The spacecraft will no longer be able to return to Earth. In 40,000 years, Voyager 1 will pass very close to the star Gliese 445, which is located in the constellation Camelopardalis, and it will continue to travel through the Milky Way. His twin brother, in addition to encountering a cluster of comets near the solar system, will, after the same amount of time, fly near the constellation Andromeda and the star Ross 248, and then will move towards Sirius and Canis Major. It's sad to realize that we definitely won't live to see that. When the Voyagers run out of fuel, they will still be able to travel through the universe, but they will no longer be able to send data back to Earth. From 2034, we won't be able to learn anything more about Voyager 2, and from 2040 about Voyager 1. That's the story. So which of the spacecraft turned out to be more successful? Here's the answer. You can't say that Voyager 1 or Voyager 2 is better. Each proved useful in its own way. For example, Voyager 1 was the fastest, while Voyager 2 was the hardest working. Which spacecraft's work did you like more?